Okay, first, I am curious to hear by the raise of hand, how many people here know what Docker is? Wow, that was a lot. I prepared a joke, but I'll tell you the joke anyway, because I thought that a lot of people would not know what Docker is, and I'd never seen so many people in a room going to a session where they don't know what the topic is. But I can't say that because like over half actually raised their hand, so maybe we need to skip all the slides about what Docker is. But anyway, so the journey with Docker started beginning of March or maybe July, but in August or July. In August, we actually started getting people into a private Docker repository with NAV on Docker. And since then, since end of October, just 3 weeks ago, we have had NAV on Docker in the public Docker hub. Since then, there's been a lot of tweets, a lot of blogs, a lot of different things on NAV on Docker. And everything very positive, everything everybody very happy about that. And we are going to talk about today what all of this is, because it started much earlier than that. On this slide, it says up in the corner that there was 4,200 pulls. That was when we created this slide a few days ago. It's actually 5,600 pulls today, meaning that 5,600 times somebody has said Docker pull a NAV image since 3 weeks ago. I think that's amazing. But first, for the presentation, my name is Freddy Kristiansen. I'm a technical evangelist in the Microsoft Dynamics NAV team out of Copenhagen. I've been working on this from the Microsoft side, and I've been working together with these two gentlemen who will present themselves.
Hello, my name is Jakub Vaňák. I'm from Czech Republic, but I'm working for a Spanish partner. We started with Docker approximately 1 year and something ago to experimenting with NAV. And during the last 6 or 7 months, we have been running all new instances just on the Docker. So, Tobias.
My name is Tobias Fenster. I'm from a German ISV called Axios Infoma. I think together with Jakub, I kind of kicked it off last year, like almost exactly a year ago, where we tried to get NAV running inside a Docker container, where Microsoft didn't try that, or at least didn't let us know that they tried it. And together with Jakub, I managed to get that to work and to run, and then we got kind of some interest by Freddy, and together we worked to implement that. What we want to show you is give you a brief introduction of what Docker is, then get into more details about how NAV works on Docker and what, from our point of view, are the main benefits of running a Docker container for NAV. And in the end, we'll talk about what Microsoft actually is shipping there. And if we have time, then we'll go into some advanced topics, but that depends on how well we go through all the other stuff and how many questions you have. So an introduction to Docker and Windows containers. We'll talk about Docker on Windows Server, because there are some slight differences. It's mainly basically the same on Windows 10, but there are some slight differences that you might run into. But today we focus on Windows Server, because it's a bit more stable, it's a bit more mature, and you're able to run that on a Windows Server a bit easier. So what is Docker? Basically, it's the leading cross-platform software container provider, software container environment. There are a lot more, with also a lot more of history in Linux, but Docker kind of kicked it off for the, so to speak, mainstream, and on Windows there's only Docker for containers. What is a Docker container? What is a Docker image? A Docker image is kind of a template of what you need to run an application or to run a service. So it's the minimum OS that you need, the minimum binaries, libraries, and the application itself, which allows you to do something like a very, very small image that only exactly contains what you need to run your service, to run your application. For NAV, it's a rather large one, because NAV depends on .NET and a lot of different and additional things, but the idea is to bring everything together that you need and include nothing that you don't need, to have as close as possible to the minimum image. And then what's a container? It's an instance of that image. So you basically tell Docker, this is the image that I want to use, and now create me an instance because I now want to run exactly that. It has an immutable base, which is the basic image, and then you put your changes on top of that. So you change configuration, you add logs, you add data, and that obviously changes, but the base image just is always the same. And what also is important is that while there are many things where you compare them, a container really is not a VM. It's not a VM Lite, it just isn't, it's something different. Especially you don't have a graphical user interface, you connect to it through remote administration tools or PowerShell or command line, but you can't RDP into that. So at least for me, when I started off, I went looking for, okay, now this starts, it works, how can I connect to it? How do I get my RDP connection? And just to save you time there is no RDP connection. So what is a Docker host? To bring this to an end, the Docker host is the environment where your containers are running. So that's where your containers really live. To give you a bit of a comparison or to better understand why containers are or help you to solve some of the problems that virtual machines have. If you think about virtual machines, you have that big ship, so to speak, which makes sense because we're talking about containers, but let's just think about your virtual machine host as a big ship. Then you're kind of putting small ships, which is your VM images, your base VMs, including your operating system, onto that ship. And then you add the workload that you want to actually run, being it NAV or SQL Server or IIS or something completely different. With containers, what we do is we remove that because we don't actually need it, at least not for the purpose that containers serve. And that means that you can put a lot more of the actual application payload onto your host. It means you get a lot tighter packing of your applications and the services that you want to run. So when we're talking about image storage, how do the two compare there? If you think about a VM, you have the first VM that brings the guest operating system, Windows Server, then it brings the binaries and libraries like .NET or something else, and then it brings, for example, NAV 2016. Now, if you want to bring NAV 2017 or a different CU for that matter, then you bring the whole stack again. It's basically exactly the same for a lot of intents and purposes, but it is just stored again. So if you have two VMware images or Hyper-V images or whatever, you have double the amount of space that you need to store that on your disk. And then if you bring something completely different, then it's the same again. For Docker, when you download the first one, you also get all that you need. It actually is a bit smaller, or actually a lot smaller, because we're using Windows Server Core, so it's not your full Windows server. But again, I have to download all of that. But it gets interesting as soon as I'm downloading the second image, the second Docker image. Because now I don't need to download the Windows Server Core, the base image again. I'm just downloading differences. There's a mechanism in Docker that's called layering. And if I have the base layer, then I don't need to download that again. They store a MD5 hash of those layers, and they just compare, is it using something that I already have? Then I don't need to download that. And it gets even more interesting if I'm using NAV, because it's using the base binaries, it's using the base libraries, and again, I'm only going to download the difference. And you can imagine that is even more true if you're downloading a CU or something. So I'm really using my disk space better in that regard. And during runtime, again, if you're thinking about VMs, they are just bringing the whole operating system, the binaries, the service, the actual application, all of that is running. But for Docker, we don't bring the base operating system. We just reuse the base operating system that's already there. So that means that if you're running multiple containers, you're just running one Windows server, and that's the one that's running on your host. All the containers that are running are not bringing their own Windows server, they're just reusing what's already there. And that also allows for tighter packaging of your payload. And if you're talking about instances, so the different containers that are running, then it gets even more interesting. Because if you think about having, for example, 3 NAV 2016 VMs running, and there's the first one, and then you change a configuration file in the second one, and you change some binaries in the third one, then you still have the full images running. Because of what I told you in the beginning, that there's that immutable base and only the changes are stored in Docker, it's different, because again, the first one is using all the storage that you have, but the second one, where only the change is in there, uses only really the part that is changed. And if I have something bigger that changed, then it's obviously going to be bigger. And over time, while the containers are running, the differences are going to go bigger and bigger. So you're losing kind of a bit of that advantage, but the theory or the concept behind that really helps to better use your resources again. So how does the resource sharing work? In the beginning, if you don't change anything, if you just run your container, as we'll see in a minute how that works, the containers are able to reuse the resources as they are on the host machine. So in that example, you imagine a host machine with 4 cores and 8 GB of RAM, and you have 2 containers, and they're just able to reuse all that. So the first one could use as much as it gets, and the second one can use that as well. But you can also restrict that and tell it that container A is only able to use part of that resources, and container B again is only able to use part of that resource. So you can make sure that while they are already using less resources than other environments, you are also able to restrict how much they are going to use on a maximum level. That doesn't mean that container A starts with 2 cores and 4 GB of RAM and they are blocked, but it means that it's allowed to use nothing more than what you restrict them to do. For networking, because that is something that I at least have struggled a bit when I started with Docker, to give you an idea of how that works, you have your host machine, in that example connected to a 192.168 network, and then you have your container, and in that example I used an IIS container on port 80, so that gets its own container network, and it's completely different than the one you have for your host machine. That's what's called a NAT network in Docker, and that means that if you have a browser directly on your host machine, you can connect to that container using that IP address. Depending on your setup, name resolution might not work, but the IP definitely will work. You can connect there and you can use port 80, so that works. But if you're leaving your host machine, then it's a different story, because if you have another machine, your laptop or another virtual machine or whatever, and it tries to connect there, it can't in that current setup, because it can't see the network of the container, so there's no way to connect it to the 172 network, and also there's nothing running on the host machine that would allow it to connect to the 192 network. But we can solve that through a number of different solutions. One is something that's called port mapping, and that means that you map the port inside of the container to a port on the host machine. For demo purposes, I changed it to make it clearer, but I could also just map port 80 in the container to port 80 on the host, but now I'm connecting port 80 on the container to 81 on the host. So that means that from externally, I can now connect to it using the IP address of the host machine and the port that I mapped to it. So bringing it to 192 and port 81 works, while the internal network still is not available. So with that, if you're wondering how to connect and why can't I reach that and why can I reach that, that's the solution for that. And the other solution for that is that you can allow the container to reuse the network connection of the host, and then depending on your network setup, that might get its own IP through DHCP, or you can set up static networking depending on what you need. But that would mean that the container gets an IP address in the same network, and you can just use the ports as they are. So I would then be able to just connect to port 80 on that IP address, and again on the host machine, now there's nothing running, nothing listening on 80 or 81, so I can't make a connection there. And the last aspect of resources in Docker is the file system. As I said in the beginning, each of those containers lives kind of in its own file system. If you're coming from a Linux background, this is something like a change root. So you're mapping part of your file system, something that's deep down somewhere in program data Docker, to the base file system in your container. So ctemp in your container is somewhere in your host, again in a temp folder. And if you look closely for that, and if you search your file system, then you can actually find it. You can see the files that are there, but you shouldn't directly use that because that might not work in the future. But what you can do is something that's a volume. I think that will also shown in the keynote. And what that basically does, it tells the Docker environment that I have that folder on my host, and I want to reuse it as that folder in my container. So in my example, I'm using cdata container temp, and that should be mapped to ctemp in my container. What that means that if I'm doing something in the container in ctemp, then that will automatically also show up in the host, and I can work with my data there. That's typically used for configuration changes, or I want to use something inside the container from my host, or I want to share something between different containers. Then I can use that for my volumes. So that should give you a basic idea of how Docker works. I hope I didn't lose all those that already know about Docker and give those who didn't know yet a basic idea of what this does. And I'll hand it over to Jakub to show you a quick demo.
Okay, so I hope we can see the resolution is okay.
That's fine.
Okay, so the first example is just to show you how easy it is to run NAV on Docker. So we have a very simple example here. I will start it, and then I will describe what every parameter means. So we are using docker run command to create new instance, new container, and to start it in the same step. Then the last parameter here is the name of the container we want to run. And you can see we have two more parameters here. The first one is mandatory. You need to accept end user license agreement. In the other case, if you do not do that, so you will receive this error. So you need to accept end user license agreement. The second parameter is about the memory restrictions, and it's necessary to specify this parameter especially on Windows 10. So if we go to terminal, you can see we have connection already prepared, and we can take this URL. We can go to browser, we can paste here, and we should be able to access the container. Okay, we can see the error because we are using self-signed certificate. So one of the output here is the username and the user password, because we haven't specified any authentication method, so the container itself creates for us one user with a random password. So we need to take those credentials and copy them into the authentication screen, and we should be able to access NAV.
And while we wait for it to load, that's the first scenario that I talked about. We didn't specify anything on the networking side, so it just uses an internal IP, as you've seen here, and we connect from the host itself to the machine. That one now isn't available outside of the host, just inside.
So, can switch.
Cool. So that was the first very simple run of an image on Docker, and that was one of the scenarios that we wanted to achieve with having NAV on Docker, that you should be able to run that with the simplest commands of them all, and of course accepting the EULA there. So how is the NAV on Docker image actually created? Tobias talked about the layering. The NAV on Docker container image is based on Windows Server Core. It's actually based on a .NET image on top of Windows Server Core. And on top of that, we install the prerequisites for NAV, SQL Express, and IIS, and then we add some scripts. This part of the image is what we call the generic image. That's the same image that works from NAV 2016 RTM and until the developer preview today, and NAV 2018 as well. And that's the same base that's used for all. So when Tobias downloaded a version of 2017 and 2016, all of this is the same, and that's the majority of the package when you download these images. Then the next thing that happens is we add parts of the DVD, only parts of it. We don't add the entire DVD, and then we run the install scripts. So the install scripts were added in the generic layer, and then after that, we actually remove the DVD again, so you won't find the DVD in the Docker image. You'll only find a running NAV in that container. This is what we call the specific image. This is a version of NAV, and you'll be able to download that by saying docker pull Microsoft Dynamics NAV, what version you want, and a dash, and then the release you want. And the release would be the cumulative update, or the RTM, or dev preview, or whatever. On top of that, of course, the localization, the country database, the specific image would be W1 without the country database, and then 20 more images would be the localizations, and there you'd have a naming strategy called saying Dynamics NAV, version, release, and then dash, and then the country code. On top of that, you could imagine that partners could create their own images, but we will talk a lot about why it shouldn't be necessary. The problem with creating images on top of our images would be that you very quickly become like your image becomes stale, right? Because our images are updated every month with the cumulative update, and I'll even talk about an even more frequent way of getting images from NAV later. So this is the format of our images, and actually you can omit the tag totally. So if you say docker pull Microsoft Dynamics NAV and nothing, you'll just get the latest version of NAV and W1. Today that is 2017 CU12. In a few weeks from now, that will be 2018 W1. Dev preview is actually out there as well. So if you want to run the developer preview, it is also on the public Docker Hub. When you start a specific image, you saw some of this when Tobias ran the image a moment ago. It printed out starting SQL Server, starting all of these things. So what happens there is a number of things, and please pay attention to the if necessary here, because it will only start the SQL Server if necessary. The SQL Server is installed and is included on the Docker image, but you can of course use a SQL Server that is not that you can use Azure SQL, you can use a SQL Server on another Docker image, or you can use the SQL Server on the host. And if you're using a different SQL Server, then of course we're not going to start the SQL Server, and it's not going to use any memory or any CPU power on the actual image when you're running that. The same with the IIS. If you specify that you want to run the web client on a different machine, or you want to not use the web client at all, then we're not going to start the IIS. We're not going to create the certificate if you have specified one yourself. We are going to reconfigure the service tier and start the service tier, because that's kind of the entire intention of the NAV container. Setting up web client file shares and setting up users is also optional and only be ran if actually necessary. Gives a picture like this, where you actually can run a number of different images on the host, some of them only running NAV, some of them running SQL Server and NAV, and the web client and everything. So, one of the most frequent questions I get is, can I use my own database? Can I use all of these things? And yes, you can basically do everything. And of course, there are a million ways to set up NAV. A million is probably even too small. There are so many settings in NAV, and we have not just added all these settings as parameters to Docker run, because then your Docker run statement would be like kilometers long. Instead of that, we've created a way of extending on the fly your container, and I'm going to talk about that now. Some of the scenarios we talked about, and this is where Jakub and Tobias was very helpful in the beginning of this project, was what are you using this for, right? How are you using that, and how are you developing in NAV using containers what you have now? and to get kind of requirements in on all the different scenarios where they use NAV. And the last line was kind of, I just stopped and said, there's so many different ways, it's impossible for me to create configuration keys or whatever for all of these things. So what we did was to create a extensible foundation. If we look at starting a container, everything happens in a PowerShell script in the container called NAV start. NAV start will like sequence a number of things like set up variables, set up database, set up configuration, set up web client, set up web configuration. All of these things will be sequenced, so it's calling a number of scripts. These scripts are placed in the same folder as NAV start. But before actually running that script, it looks whether there is an override of that function in a my folder underneath the run folder. And if there is, it's going to invoke that script instead of the original script. In some situations, you want to invoke the default behavior. Setup configuration is a good one. You want to invoke the default behavior because the only thing you actually want is to change a few settings, maybe maximum download size or whatever from your service tier, which we don't have a configuration key for. So you can either invoke the default behavior before or after your custom code, right? And there are a number of different things that you could override. This example will set some settings like disable buffer inside if you're running that in a developer environment, right? So this is just a part of the setup configuration part. A number of these scripts are actually empty, like the additional setup is a script that is called at the very, very end when everything is set up. It calls this function, and the function that is in run is just empty and will do nothing, and that is for you to override so that you can do stuff like import users or register DLLs that you've copied to the image or whatever. All of this means that you, on the fly, can add your scripts and actually run them when you just launch the container using the mapping that Tobias talked about a second ago. You'll place your scripts in a folder and share that to the container in the my folder, and then the container, when it runs, will have your scripts there, and you'll be able to extend or customize the container in every way you want. A number of the different extension points: set up database, add-ins, license, variables, web client, and all these things. Certificate is another one. And right now, you actually cannot specify your own certificate without overriding it with a certificate script. Maybe some of the things will be added as parameters to the Docker run, maybe not. It depends on how many people are using these things and what the requests are. So next demo, extending the container.
In the second demo, we will show you how to extend the container.
I don't think you're on. Can we get the mic on?
Hello?
Try again.
I haven't changed that.
No, just talk.
Hello?
Is number 3 on?
Hello, hello?
Ah.
No. Okay, so the second demo will be about the extending of the standard functionality. You can see that I have a subfolder here called my. In the docker run command, I'm mapping this folder in this line. I'm saying, okay, Docker, take my subfolder and map the subfolder into C run my inside the container. So at this moment, Docker takes my folder, copy the folder inside the container, and will apply my scripts I have in this subfolder. So you can see I have additional setup PS1 file here, and you can see I'm still calling the basic, the default behavior. It's not necessary exactly in this case because the original file is practically empty, but I'm doing it for best practices. And I'm calling here a function called export client folder. This function is being implemented here in this extension. This is the second one. I'm extending helper functionality. And again, on the beginning, I'm calling the standard behavior from the standard image, and then I'm adding my custom functions. And this is the function I'm being called from additional setup here. So this function specifically export my role-tailored Windows client folder and copy it into my host machine. And additionally, it will create some a new exe file that will allow me run C-side directly from this folder. So we have already started the container to speed up the demo. You can see I'm already on. I'm going to the folder. You can see that this folder has been already created. And you can see a new file here, finsql on docker.exe. And actually, this is PS script inside, wrapped as an exe file, and has all parameters necessary to point directly to the database. So you can see I've been able to enter directly to my container, which is called navx. So this was one of the possibilities how to extend your or how to extend the standard functionality. You can, for example, create. You can, for example, use the extensibility for creating or adding your users from the domain to the NAV, or you can use practically anything else. Okay, that's it.
Just maybe to add one thing there. As you saw, Jakub was using the standard behavior as well, calling the standard scripts, but it also is something that is optional. I personally haven't seen a use for where I just completely remove the standard behavior, but the extension mechanism works in a way that if you know what you're doing and you just want to do everything yourself, you could remove the standard behavior as well by just not calling the standard.
Actually, calling setup certificate, you don't want to call the standard behavior.
Yeah, that's right. Okay. Building and reusing your own images. The next part now will be about how you can use that for your intents and purposes, where it will help you with problems that you might have today. I hope you have got an understanding of what Docker does and how the NAV on Docker images work. And now I'm going to talk a little bit about what we solve with NAV on Docker and why we looked at that in the very beginning. So the first one is building and reusing your own images. The problem there is that you extended the standard NAV Docker image, maybe because you add your own DLLs, you change a setting, you change a configuration, you do whatever you want to do, and now you want to make sure that that change is persisted and is doing the same across all environments. The reason for that might be, for us as a partner, we want to make sure that the changes that we make to standard NAV, not inside of the FOB files or the CIL objects, but the changes that we make to the binaries, to the configurations, the things we add, that can be reliably delivered to our customers. And I guess the same is true if you're running that for yourself, or if you're a hoster, then you also might make changes to standard NAV, or you might make changes to whatever a partner provides to you, and you want to make sure that this is really persisted and works the same all the time. And then there is the so-called doesn't work here problem. When you have something that works on a developer machine, it works in your test environment, it works in your quality assurance environment, but for whatever reason it breaks in your production environment. Or it doesn't work at the customer, but it works in all of your internal environments. And that just sucks. the reason for that is oftentimes that there's one simple configuration that is different, or they're using a different base Windows image, or for whatever reason a .NET fix was implemented, .NET framework fix was implemented, an update is there and it just breaks. Or your developers are using Visual Studio, so they have some libraries that are just not available in your running test environment. And all that can be solved using the Docker images, because you are absolutely sure that the Docker image is always the same if you push it to a central registry. You are absolutely sure that the configuration is the same, that the binaries is the same, the libraries are the same, and you don't have any differences between that. And that works by just creating and reusing your own images. And there are a number of different ways. We just showed you how you can extend the standard images to make the changes that you need. And then you do something that's called a Docker commit, which means that you save those changes. For that, you on Windows need to stop the container, then you can commit it and give it a tag. So the versioning that Freddy talked about, and you can add whatever is meaningful to you, a date stamp or a version or whatever. And that means that you now have your own image, and that image can be referenced by that tag. And if you do a Docker pull again to load that maybe to a different system, then you're able to reference it by that tag, by that label, and get all the changes that you need. A mechanism to get this done on different systems is a Docker registry. There is a public Docker registry where you can get the public images, which is called Docker Hub, and I think we're going to talk about that a bit later. But you also have the opportunity to set up your own private registry, which means that you are able to have your own images stored in a central system in your environment, and on the different environments, NAV environments that you have, like test and QA and production, you just pull those from your own registry and make sure that you have your own images. So it's a two-step process. You make the changes, you commit them, you push them to the registry, and on the other environments, you just pull and run them. Sorry. You might also be able to just create your own Docker file. We have a very good extensibility mechanism inside of NAV, but if you're looking at other Docker files or other Docker images, then you might be forced to use their Docker files, and that actually also is kind of a good practice, because you change the recipe, and then you're also sure that the template and the image in the end looks the same. Another problem that we can solve is that of resource governance. I guess that a lot of you are in the same boat as we are, where because of some problem in development, being it your own development or whatever, you have instances that just go crazy. Or maybe a customer just called a bad report with no filters at all, and it just blows up. It uses all the CPU, it uses all the memory, and you get all the problems that come from there. Maybe your developers can't work anymore, your other customers that are on the same host are impacted, and yeah, you get a resource problem, a performance problem in all the environments. The, so to speak, brute force solution for that would be to have exactly one instance per virtual machine, but that also doesn't make too much sense. But it's a lot easier with containers, as we've seen before. You can have resource limits on those. So you can have any number of instances that just work on your host machine, and you tell every one of those that they have to stay inside of their resource limits that you can provide to them. So you make sure that you add those resource limits when running those, like I showed in the beginning, only 2 cores, only 4 gigabytes of memory, and they're not going to go over that threshold. With that, you can make sure that not one of those instances is impacting the whole host, but they're just staying inside of their area, inside of their limits. And if the main process, which in our case would be the NAV server instance, hits an out-of-memory exception, then it also is automatically restarted, the same as for the Windows service itself. In our case, if the instance stops, then the whole container stops, but Docker also makes sure that it restarts that again. Obviously, the users will lose their session, but that's just the way that NAV works. But in the end, you afterwards have a instance running, and they can connect to that as well. And then there's something that's called swarm mode, where you're able to do scaling, where you're able to do high availability. That would mean that you can actually run the same container on different hosts for a number of instances. And when one of those containers fails because it hit the memory limit or whatever, then all the others are there to just serve your requests. And the user, probably a lot of the users, will not even notice that there was a problem. And the third big one that was important for us is running multi-CU environments. The problem there is, as probably also a lot of you know or have hit that problem, that you can't run multiple cumulative updates on the same release very well in one machine. There are solutions with scripting and naming conventions that make that work, but it's not really a good and clean solution. We do have the different CUs that just reuse the same files, the same links, so I can't very well put them in the same place, and we don't have a solution for that currently without Docker. We do have the monthly CUs, as Freddy also mentioned, so that makes it a permanent problem. If you want to look at all the CUs, maybe on different release levels, then you have to put up a lot of different virtual machines to really get that up and running cleanly. And you can, again, automate a lot of that through PowerShell, but it's still a bit of a hassle there. From a customer or hoster perspective, you get enhancements, you get a solution for something that bothers you in a new CU. Now you need to update your testing machines, your staging machines, your production environments with those new CUs, and it would be nice to just have them run side by side so you can try whatever you need, and if you want to go back, you just switch off the new container, switch back on the old container, and you're up and running on the old CU again. And then there's the case where you have parallel business testing with CU testing, like you deliver a new solution to a customer, tell them to test, and you also deliver a new CU to them. Then you probably don't want to mix those two up, because if something breaks and you get a problem, you don't know, is it your new implementation or is it a new CU? And with that solution, you just have the old CU with your new solution, and you have the new CU with the old solution, and you can test both. In the end, you will obviously test both together, but you also have an option to separate those. From a partner perspective, at least for us, we don't have all of our customers on the same CU. Some of them are using older CUs because they didn't get to updating them yet. And you have the problems, you need to reproduce those problems on the exact same CU sometimes, because it's only happening exactly there. And then you have the case where you get a solution for a fix, and you need to test those as well, make sure that nothing's broken in them. You also might have additional problems, at least it is in our case, where you deliver your own custom DLLs maybe more often than you deliver the CUs, but then you also have different environments with the same DLLs or different environments with different CLLs, and you can also separate that very well and cleanly using Docker images. And in the end, you have the problem that sometimes the CU compatibility breaks, so you can't deliver a solution using a newer CU to an environment with an older CU. So you really need to make sure that you're delivering fixes in older CUs and deliver those to the customer on the right CU. And again, you have a need to have multi-CU environments. What's the solution for that? Again, containers, because you can have them running side by side. As I said in the beginning, a container instance has its own separate file system, so you don't get any conflicts with the NAV server and with the web client, because that's all running server side. We can have click once clients for the Windows server as well as for the development environment, or you can use the technique that Jakub just showed by sharing that environment to your host machine. If you're running in a distributed environment, then that doesn't really work, but if you're just talking about dev environments, that also works very well. So with that, you're able to develop against those solutions, you're able to run against those solutions or that CU that you really need. Updating that, again, is only a simple Docker pull. So you have your test environment, you have your quality assurance environment, you just do a Docker pull there of the new CU, of the new version, you have the new one, you run it, you test it. If you're fine, you keep it. If not, you just throw it away and go back to the last one. So that really helps in running those multi-CU environments. And those were the three main topics I wanted to talk about. There's really a lot more talking about Docker, especially around continuous integration, continuous deployment. A lot of those things also work very well inside Docker and help a lot in connection with the new development environment as well, but I wanted to keep it at that level. And we'll now see how running those multi-CU environments actually works.
So as Tobias already said, we in Marques Olivia, we were facing the problems with running many customers with different CUs. So for me, this example is one of the best ones. We have in this example, we are running 2 different CUs of 2017. We are running CU6 and CU7. So we have already started 2 containers. The containers are already on. We are using click once to publish the package into the host machine. So we have already, to speed up the demo again, we have already downloaded this image, this package, and I can show you that here, if I'm going to NAV, I will be able to see that I have 2 different instances, each one with the different build number. This is 16996, and the second one is 16585. So you can practically run 3 different different versions, and for each version on the same host you can run unlimited number of different CUs. So from this perspective, Docker, I think it's a really strategic tool and platform. So.
Cool. So what you've seen until now is a number of ways to run, like Docker run. You can and that's what I call the raw mechanism of running Docker images. You need to go to a command prompt, you need to run these things. You can do it from PowerShell, yes. But of course, it's possible to automate some of these things. It's possible to do things easier. And for that, we've created some PowerShell scripts that makes life easier when working with NAV containers. Not surprisingly, it's called the NAV Container Helper. And it's an open source project on GitHub. So go to github.com/Microsoft NAV Container Helper, and you'll find a PowerShell library that you can download and start using these high-level commands, which makes it way easier to run with NAV containers. So I'm going to demo some of these here, and actually you don't have to download the PowerShell script. You can also take it from the PowerShell gallery. So just go in and say install module, NAV Container Helper, and then you'll get the NAV Container Helper. Some of the commandlets in that one, new NAV container, guess what it does? It creates a new NAV container. And then there are high-level commands like convert modified objects to AL. That's a nice one. I'll show you that in a second. Let's go to, on this machine actually, to PowerShell here and have a look at how this module looks. So I've already installed the module here. It's really done just by this single line. Install module NAV Container Helper Force. That downloads it from the PowerShell gallery, and here are all the functions that are available in the NAV Container Helper. So there's a number of functions on that can give you information about the container that's running or the container images. There's container handling functions, there's object handling functions, which are specifically nice if you're working with V1 extensions and want to convert them to V2. App handling functions for publishing and unpublishing and installing and uninstalling apps, V2 extensions, or actually V1. And then a Azure VM specific function for when you're running this inside the Azure VM. When you're running the NAV developer preview, it actually starts up an Azure VM, downloads this module, and runs the NAV Container Helper. New NAV container in that one, and creates the container using that functionality. And that's where, if you have an Azure VM and you have maybe polluted the database inside of the container, you just run replace nav server container, and it creates a new container for you, and you are up running as if the machine was brand new. Let's have a look at some of these things. So I will first of all run this section and talk about it afterwards. So it is going to ask me for a password, and that's the get credentials. So it gets my credentials and stores them in a safe way in memory, and actually the new nav container will transfer these credentials in a safe way to the container and remove the key file that it used to transfer the credentials to the container. So nobody can grab your domain password out of the container afterwards, and that is a little hard to do if you are not using PowerShell, because you need to create a key and you need to encrypt your password with that key and copy that to the container and remove the key again. So that just all happened automatically in the new nav container. When you're running a new nav container, it talks about, it tells you what version it is and what generic tag there is in that version, and then it tells you that it shouldn't take more than a few minutes to complete that one.
Maybe a quick note on that, if you can switch on. Yeah, thanks. We've seen a lot of feedback around those on the GitHub repository that Freddy will also show later. And it also definitely makes a lot of sense if you just show exactly what you're doing there. So show the output, show the commands that you were running, then it's a lot easier to help. Because some people have posted issues, this and that is not running without giving any feedback. And if you just post that output, tell us what version you were using and how you ran those scripts, then it's a lot easier to help.
Yeah, so that output is not this, that is the output I'm going to show here. So now we are running one container. It's called test1, and I can get the logs from this one by saying docker logs test1, and it's going to show all the output that actually was shown when Jakub did the Docker run a moment ago. So this is one of the important outputs that we want if there are troubleshooting issues. The other important one would be the Docker inspect of the container, which talks about, again, your network up settings, your labels here, what was used in order to start this one, and your environment variables here. I can have a look at Docker PS and see what images I have running here. I have one running, that's the test one. I can go Docker images and see what images I have on this machine, and as you can see I have a lot, but they are only taking up very limited amount of space on my hard drive, even though they seem to all be 15 gigabytes. Then most of the things that are in these images are actually shared, as Tobias talked about earlier. So it started my test1 container here, and I should be able to start the development environment. And actually, one of the things that the new nav container does is it. Let's see if I can get to my desktop. I'll have to cancel that one. It creates some shortcuts on your desktop. So you will actually have a test1 C site here. And I can double-click that one and get right into my C site. And I'm now connected to the SQL Server inside of my container. And as you can see, if I go all here, modified objects, F7, yes, nothing has changed in this one. I will run a PowerShell command that's called import objects to nav container. Guess what it does? It imports objects to my nav container. Now it's done, so I'll go in here and refresh, and let's see, view, refresh. And now I have two objects that have changed. So I just imported two from a text file, and I'll modify some more. Let's go in here and go to the beginning, find my customer table, and add a field. Control Ent, 50,100, test. So now I've done a modification to the database as well. Saved it, and I have now three objects, two that are added and one that have changed. Let me then try to go back here and have a look at what does export modified objects as deltas do. Well, that's kind of hard to guess, right? Here you get a I actually asked it to open the folder with the open folder switch. And it opens the folder with 2 text files and a delta file. And that is your deltas. It is still in the old syntax because I didn't specify that I wanted to have it as new syntax. I can do that by simply specifying -use new syntax. And then I'll get it in new syntax. Should I try that? You should never change the demos while running on stage, but let's try. I'm pretty sure it will work. Now this is a new syntax, and actually there's not much difference there, but I will be able to see the difference if I go into these things and see that the date and time are actually now in the new format. More interesting is it probably to be able to convert that then to AL. So convert modified objects to AL. Does exactly what the name says. Converts all the modified objects in that container to AL and puts it in a folder for you. And you can take that folder and move to Visual Studio Code and start developing there. Or you can find if there are a lot of errors in the conversion process or a lot of errors in AL, and then go back and modify them in V1 before you actually do the transformation to AL. It's a one-step process to take everything you have in that container and make AL out of that. Of course, behind the scenes, it uses the text to AL that Esben showed on the very first day of Visual Studio Code. And so there's nothing here except for wrapping all the functionality that is in the platform and making it easier to call. So it creates the deltas and do all of these things to make it easier to run. You can stop containers, you can start containers and all of these things, and you can start up multiple containers. One of the things I wanted to show here is this thing with, in the good old days where you, whenever there was a new CU, you would have to download the CU, you'd have to put it in a repository somewhere, you'd have to install it on some machine. The ease of which to run different containers is, the difference is just a string, right? If you want to run 2016, you write 2016. If you want to run 2017 CU8 DK, that's what you write. And everything is included in that string. You'll get that image, you'll be running that in a container. I can start all of these if I want to, but I don't think there's any reason for that. I wanted to bring your attention to this one. So this one says Docker pull nav insider.azure.cr.io Dynamics nav daily. Now, the insider program, I'm going to touch upon that a little later, is when you are an app developer and you are registered for the insider program, you'd actually be able to have daily builds of NAV right there on Docker. And some of the things that you'll be able to do with that is to make sure that your application is not broken, right? You'll get a build in a month or 2 months from now, and you're gonna try your application, and you'll see that, oh, something was changed, and my application is now broken. In the next session in this room is Søren Clemmensen and Jonas. They're gonna show you the a GitHub integration where you'll do source code control of your application and actually do automated daily builds of your solution. So whenever somebody checks something in, it's going to move to a machine that builds this, and it can actually just automatically download from Docker the latest build, and you'll be sure that you didn't break anything and Microsoft didn't break anything, right? So you will know every day whether there's something that is broken, not in half a year from now where everybody forgot what the heck we did half a year ago. So I think that's a very nice thing. I'm not going to start a lot of these containers. I think we will continue here and talking about oh, that's not what I wanted. Sorry about that. I'll just keep it here. Let's go to the next one. So, that was a demo of the NAV Container Helper. NAV Container Helper is an open source project, so I urge you to have a look, try it out. If you have something that you think, oh, this should be done in a different way or whatever, feel free to submit a pull request and we'll have a look at that. It's really a tool which is intended to help you guys. It's not intended to yeah, it's really intended for people working with containers to have it as easy as possible. So please help us make it easier for you guys. So what are we shipping? So right now, every cumulative update of NAV 2016 and 2017 on-prem are also on Docker. So they are also on MSDN. You can download the DVDs, but there are Docker images out there. That is 25 cumulative updates, 26 actually, of 2016 and 13 of 2017, RTM to CU12. That is a total of approximately 800 images that are up there because we have 20 localizations for each image. And they're just there ready to download. The reason for this is, of course, as Jakub and Tobias have talked about, if you need a specific CU because that's what your customer is running, then it's just easy to get, and you can just say Docker run that one. It's also for our CSS guys, so whenever somebody reports an error, in 2016 CU5, they would spend a day of actually downloading that one and setting up a machine and installing everything to be able to do a repro of that bug. Today, it's a minute or two, and then they're up running with that cumulative update and can actually start reproing the bug. Soon, of course, 2018 on-prem will also be on the Docker Hub. Important to realize it is, at this time, supported for test and development. It is not intended for production purposes. At some point in time, I think we will support production environments as well, but that is not supported. That's not intended for that and supported for that purpose now. So the images that we have on Azure, we have Azure demo environments, we have financial sandbox environments, and the developer preview. Actually, the developer preview is there now. Okay, yeah. So the developer preview and the workshop VMs are on Docker now, and they are only on Docker. You won't be able to get the developer preview on DVDs, and you won't in the future either. Soon we will take the demo environments and the financial sandbox and move that to Docker as well, and remove the images that we have on Azure. The image that spins up when you create the developer environment or the developer preview or the workshops is not an image we've created. We're just spinning up a standard NAV Windows 2016 with containers. That's an image from Azure, and then we are running a Docker container on that one. So it takes some minutes, but it makes it much easier for us because we don't have to maintain images with a lot of different stuff on it. And we are sure that you always get the latest version of everything if you spin it up.
Maybe I can add one thing there for the NAV workshop VMs. That's what Freddy uses, Microsoft uses for their workshops at Directions, for example, or here. But you can also use them for your internal purposes because they are now openly available. For example, we have a couple of customers over every time we release a new version, a new major version, and have them test. And that also used to be quite a pain to set up those environments. And with those scripts and the template that you have there, you can very easily spin up multiple, even up to a couple of hundred VMs on Azure, with exactly that CU that you need, that version that you need, fully automated, and then you're just ready to do the workshop, the testing, or whatever you need.
Yep. Going forward, we will be going into a 3-ring release cycle here. So stable, if you've seen Visual Studio Code, you know that you can go to Visual Studio Code and run the insider builds, or you can run the stable builds. So one is what's shipped, and one is what is kind of their daily builds. We're not going to put daily builds out there for everyone. We're going to put daily builds out there for our partners who have a relationship with us in one of our developer programs. The stable ring is also on Docker. It's releases, it's cumulative updates, it's the current SaaS builds and stuff like that. You'll be able to find the current SaaS builds, of course, online, and you'll be able to run the releases or download the release and the cumulative updates from MSDN, or run them from Docker. Whenever we are talking about insider builds, meaning like daily builds or bi-weekly builds or monthly builds, we'll have 2 rings there. We'll have one ring which we call the SaaS preview. That is the version that we're going to publish to our SaaS servers the next time. So our partners can actually get the build that will be published within the next month to our servers, and make sure that they have everything there. And partners will also be able to run or download and use daily builds. Of course, with the caveat that things can be broken and stuff like that. But yeah, that is something that we would like to hear also if things will be broken, of course. That's the communication on new builds and stuff like that will be on the team blog. Collaboration on GitHub. The NAV Docker repository on GitHub is where the source is for the generic image, and that's where issues are reported and issues are resolved. Documentation will be on MSDN and on blogs. I have posted a number of blogs on trying to document all of these things, and my next topic to document is the NAV Container Helper. And I'll be going through a lot of that over the next few weeks or so. So I think the next thing here would be questions. Unless you guys have any more to add. Where do we have the t-shirts?
So, does that work? Oh, yeah. Thanks.
Hi. Okay, so I have a question. What about older NAV builds? Is it even possible to run them on Docker? And maybe you have some recommendations how to do that?
You mean older than 2016?
2030. No, 2013 R2, for example.
Yeah. So 2013 R2 and 2015, we did not include those in the Docker images because they are significantly different from 2016 to install. We're definitely not going to do 2013 R2 because that's out of support in very short time. We might be looking at 2015 if the request is big enough.
Without any official support, but when I started off, I tried to install 2013 R2, and there are a couple of things there where you would need to do really ugly stuff that you actually don't want to do and definitely would want to do in production. But I think you should be able to get your own images, not built on this, but really your own images for development and testing purpose. That should be possible.
I think they could use our repository, our private, our public repository on GitHub. It's still live there.
Yeah, when Jakub and I started, we had a GitHub repository which was different than what Microsoft did, and you could check there how we implemented things back then. We used the installer, we did a couple of tricks to get it up and running, and you should be able to use that. If you go to Jakub's GitHub repository, which was also on the slide, you should see that as well. Yeah.
If you want to use it in development environment and also for automated testing, as the server core is headless, have you run in any issues? Because if we want to also test against third-party solutions or our own developed stuff, so that we can run the installer fully automated through PowerShell, are there any issues that you run into, or that you had some software installers which could not be automated like this?
Yeah, there are a couple of things that just are not possible if you don't have a GUI. I haven't seen anything that should work on a server side, but if you're talking automated testing, you might want to do some of the things that are actually on a client side inside of the container, and that might be problematic. So you could look into having the client side still as a traditional client and just spin up the containers to ease that. But if you...
It's more that we need some Windows services where we then talk to through web service.
Okay, so if you're talking to something completely different, then you need to look into if Windows Server Core supports that. And I personally haven't seen anything that's not supported or that doesn't work yet. The issues only are if you really need a client and a GUI for a client, then you have a problem. But if it's running on a server side, if it's a service, then there are good chances that it works. Not everything works, but a lot of it.
Can I choose my own SQL server when installing Docker for multiple Docker images?
So the question was what?
Can I use my own SQL server instead of using SQL Express?
Yes.
To install the database.
Yeah.
It's just a parameter when you start a Docker container, you tell it you want to use that server, you want to use that instance, you want to use that database, and then the container just connects to that. You have to think about how authentication works. So how do you authenticate the container, the NAV server instance inside the container to the SQL server? Are you going to use Windows accounts? Then that's a bit more that you need to do. Or are you using SQL database accounts? Then it's actually quite easy to do.
When you use like a Docker daily update, in that case, it will automatically update that SQL server also, like image.
Say it again, please. I didn't catch it.
When you use a Docker refresh, like image refresh, like that time, if suppose Microsoft added few more tables or objects to that image, then it will automatically update to your SQL server as well.
No.
Okay.
It's exactly the same as if you were installing a NAV service tier and connecting to the database.
Okay.
There's no magic there. It's the same scenario, right?
Okay, that's right.
What it brings is it brings the new database inside the container. So if you're using the one inside, you don't have that problem. But if you're using your separate, then for intent of the SQL server, the NAV server instance inside of Docker is just the same as any other NAV server instance that's running outside of a Docker image.
Okay, that's good. Thanks.
Is it possible to use existing SQL Server installation with Docker container?
That wasn't that the same question? That
Oh, okay, I have another one, sorry.
But yes, it is.
Is it possible to use, is it possible that we have the following situation when multiple Docker containers use the same database?
Again, that's exactly the same as if you're using NAV instances outside of Docker. It's just 5 instances running inside or outside of Docker connected to the same database, so you see the same issues that you see outside, and it's perfectly possible, yes.
What about resources? For example, printers?
All of that should be handled client-side. Because again, you don't have a GUI to connect to, so at least I personally wouldn't know how to set up a printer in Windows Server Core. If you want to do server-side printing, then you should probably look into having a PDF and sending that out. But you can't connect to configure.
So
the
yeah, I can connect directly. Yeah.
So you should really see this as a NAV service tier running isolated. That is what it is, right? And then we have added the SQL Server and stuff like that in order to make it easier to spin up something. So we've included everything there. But in the essence, it is just an isolated service. So exactly the same scenario if you were able to install 5 different service tiers on the same box, side by side, and they were not touching each other. That's what happens.
Okay, thank you.
You told that it's still not useful for production. Is that still far away for production, or is it something what is in nearest future?
I cannot say when or if or how we're going to support it for production. I can say that we're looking at it, but we've shipped this 3 weeks ago, and I think we want to make sure that we have tested it thoroughly before we put customers on running this.
But you will sure that it will come?
I think I said that I'm not sure that it will come, but we are definitely working in that direction. And if the demand is there and we find that we don't have any issues, then I can't see any reason why not. It is basically supporting Windows Server Core as the basic operating system we need to support, and now we are able to test it, so now we are able to do the testing. If we do, then my assumption would be that it would be around Tenerife timeframe, but I don't know.
Hello. Can you tell a few words about multi-tenancy?
Yeah, so right now, the Docker image is single tenant, but basically it is just changing a setting inside the container, and that is one of the topic that is on my list of things to add, multi-tenancy. So if you have a database that's outside the container, it is just changing the multi-tenancy flag, and then you are running multi-tenancy as well. The thing that requires a little is if you want to run the entire demo environment inside the container with the inside SQL Server in multi-tenancy. That requires some scripting, and I'm not sure, I don't know if it's worth doing or not. It's kind of up in the air.
With these extensions coming up into the 2017 or 2018, can I include the extensions into my Docker image and then probably ship it over to some other test environment alongside with the extensions so that I don't have to use the extensions or rebuild the extensions again into the image?
You can, yeah.
Okay.
Actually, what we are using this currently for is for the development of our own first extension. And this is built completely on containers, so I've never run our extension in a traditional NAV server instance, and it works absolutely fine.
Okay, thanks.
Thanks. What about performance? Is the NAV on a Docker, hosted on a Docker, is working the same as the NAV on a RAV machine?
Absolutely. I personally haven't seen any differences at all. I didn't run any performance testing on it, but conceptually it's just the process is using the host environment. Actually, if you are on a Docker host and look into the running tasks, then you can see the Microsoft.dynamics.nav.server.exe. So it really is using the CPU and the memory and the file system the same. So I didn't see anything, and I wouldn't know why it should be any different than installing it natively.
Okay, cool. Thanks.
I guess there might be, if you're running SQL Server inside the Docker image, there might be a performance hit because you're using, this.
Yes, because we used then the SQL Express, right?
Yeah, but
yes.
But the solution to that is, of course, and
yeah.
I think the Microsoft SQL Express inside the container will only be used for demo purposes,
Sure.
If you're developing V2 extensions where you really just need a container in order to be able to publish your extension and run it. So there you just need this container for having a test bed of your solution, and you're using Visual Studio Code maybe on your laptop, and then publishing to your local container, and you can do that in the plane on the way home from wherever you are. And still be able to develop your V2 extension and never get a minute of sleep anymore.
Yes, sure. Thank you very much.
And if you look into SQL Server in a container that's used more widely, there are more people who already are using SQL Server, and there are a number of blogs and people out there who are talking about SQL Server performance in a container, and at least as far as I've seen, they come to the same conclusion that SQL Server behaves just the same. You need to think about why your SQL Server is not performing if it's not, but it doesn't matter if you're running it natively or if you're running it in a container.
I have a question down here as well.
I have two questions actually. One is the test toolkit and test libraries available in the standard Docker images itself without the need to download the DVDs? And another question is, how does the monitoring of the Docker work? Do we have something like the event viewer in there?
Yeah, so the first question, I can take that. That's something we're looking at. I got that feedback from a few other guys. A few of the MVPs actually asked me for that. So we'll be looking at including those as part of the build so that the tests are there. On the monitoring, I don't know what you have experience of.
You can, on one hand side, you can use the standard mechanisms that you have in Windows Server, like the performance counters. They should be possible in the near future. They're not there yet, but you can in the future. And then also there's interesting stuff that you can do around monitoring your Docker environment. And that is basically two things. You can look at how much resources, being it CPU, memory, or I/O, is the container using. And you can also look into the container to use that performance counters. And there are tools like Prometheus or Grafana to give you a nice dashboard of what actually is running. So it's interesting, as soon as you're looking into the Docker world, then the same problems that we have around NAV and SQL, or the same things that we want to solve, you now see in a really wide world where people are doing a lot of stuff with Docker and they have the same problems, and you can just reuse their solutions. So what I'm currently working on and hope to be able to publish on my blog in the next few days is to do exactly that. How do you monitor a container environment, containerized NAV environment with something that's regular in the open source outside of Microsoft world. So it's going to show you how you can use those tools, Prometheus and Grafana, to get a nice dashboard around that performance. And my point basically there is, if you go into the Docker world, then a whole new world of tools that are already there, a very strong open source world opens up, and you can use that to manage and handle your NAV and SQL installation.
Hi, you mentioned that host platform of choice is a Windows Server, and that's something about Windows 10 as a host platform. Can you tell me, can I use Windows 10 as a host platform for Docker?
So it works with Windows 10 as well, but Windows 10 always run with the hypervisor. So you have two isolation mechanisms for a container. One is process isolation, which is what Windows Server does. It allows you to share all the resources of the host, that's what you saw here. In Windows 10, it will pre-allocate some memory and actually run up like a small VM, a very lightweight VM, but it will pre-allocate the 4 GB that you give it. So you'll only be able to run 3 machines on a 16 GB machine, right? Where on a Windows Server, I could easily start up 8 containers without any problem, because they'll be using the exact amount of memory that the service tier is using and nothing more.
Okay, so it's only resource limit.
Yeah, so Windows Server is just better at, but the version of Docker that is included in Windows Server is the Enterprise Edition, and what you can get for free for Windows 10 is the Community Edition, and that's the big difference.
Okay, thank you.
Maybe to add just one thing to that, I've seen more funny stuff in a Windows 10 environment where you have to dig deeper and find problems that are kind of uncommon. That might be because Windows 10 tends to be the laptop someone uses and they mess up things, and Windows Server is maybe more central, more controlled. And also it might be because Docker is just not working as well on Windows 10, I'm not sure. Leaning into the first direction, but I'm not sure. So just from my experience, it's very, very stable on a Windows Server. I haven't seen almost any funny things there. On a Windows 10, there are some head scratchers where you need to invest a couple of hours to get to the bottom of that, and then it works again. It's just a bit more effort. So it's just like, yeah, it's a lot easier if you run it on Windows Server, but it perfectly will run and will work on Windows 10 as well.
And for Windows 10, I think the primary usage there would be for the developer using Visual Studio Code and actually just want to run your code, you test your app towards a running service tier. And there it's perfect because you only have one, and you replace that with a new one whenever you get a new version of NAV.
You can stop them and you can start again the containers. So you can have many containers on your machine, and you can go stopping and starting them. So it's another option.
Is it possible to run on a notebook a virtual machine with the server and then Docker on it? Or is it too complicated?
No, it actually does work. We do a lot of that in exactly that scenario. It's just you need to have something that's called nested virtualization, and then it works completely fine. So it might be an additional setup that you have to make on your laptop, but it absolutely will work. So we have a question down here.
You just shout your question and we'll repeat it if it comes down. Yes.
Thanks. When I'm running into issues, as Docker is no Microsoft product, and for example, my containers do not start up, it's always crashing with some errors. Do I create GitHub issues in this case on your side of Microsoft, or is there any community, or do I need to use the Docker community for the questions, or how do I proceed with issues?
It depends on who's to blame. No, I'm kidding. I'm not kidding. No, so you can always try at the Microsoft Docker, Microsoft/NAV Docker. I have created a blog post called Troubleshooting NAV on Docker, which is a 15-item list, and those 15 items, every single issue we've had that were related to NAV on Docker is explained there how to solve them. And if we hear more, we'll add to that troubleshooting list, and it's probably going to be on docs as well or something like that. So for now, please put them on GitHub issues, NAV Docker or NAV Container Helper if you're using the NAV Container Helper, and we'll look into that and help you.
Okay.
But also, I've opened one first service request to the official Microsoft support channels for a problem we had with the container. And the first feedback, I would guess, by first level support was not so encouraging, because that guy definitely hadn't heard of containers before. But after I got over that hurdle, and that went very, very quickly, then I think there's a lot of interest in Microsoft as well by second, third level support, or even the development teams who want to look into that and who want to understand how people are using that and what problems are there. So the first impression might not be that good, but if you get over that hurdle, then there's definitely a lot of good feedback and interest in helping you to solve through the official Microsoft support channels as well. And then there's the huge Docker community. They just tend to be like 90% on Linux, because it's a lot older there. And then you have the 10% of Windows guys who are also, in my experience, very open and very fast to help.
Do you need to install Windows updates on a container?
So yeah, the Windows Server Core is updated every month as well. And when you're running the NAV container, you'll actually get a warning or an error if you're running a NAV container that is more than 90 days old. You can start the container with a -accept outdated, and you will accept that you're running an outdated container. But we'll update. We will encourage you to run the latest, and that will include the updates, of course. And then you wouldn't be in that situation. But yes, you can download and install updates on a running container if you want to. Typically, if you're running Windows Server, the Windows Server Core layer used there is actually, the majority of that is just interfacing to your host operating system. It's really not using that layer, so it's not necessary to have as many updates to that. You're updating your host, and that will be updating the majority of the vulnerabilities that are there. But yes, there are updates to Windows Server Core as well, and they are monthly like they are with Windows. So what we encourage you to do is always to use the latest image from us, and that will be updated, and then you'll be safe.
Okay, thank you.
And that would also mean you can have the latest image, but with an old CU. So you're on, for example, CU5, but you're monthly updating CU5, and then you get the monthly fixes.
We're actually not going to monthly update all CUs.
Oh, okay. So I take that back, sorry.
Now, running an update of all cumulative updates or something, we don't know if we're going to do that, but okay. I'm not going to promise it here.
Okay. Any more questions? We have one there.
Hello. Are your extension examples available to download? I like the dev environment. Is that available to download from your website or from today's demonstration? Just to save time, rather than reworking what you've already done, is it available? Yeah.
I would very much encourage you to go to Jakub's GitHub repository that you see there. Yeah. He's having a lot of examples there that make a lot of sense and will help you save a lot of time there, because he's doing, in my opinion, the most common examples that you would need to do. And if you have further questions, then just drop us a note. Might look into that as well, and I could offer it on my blog or Jakub on the repository.
Okay. Thank you.
Yeah, so everything you've seen on stage today is available either on blogs or
one of the examples
repository.
There in my repo. So
yeah. And the NAV Container Helper, of course, is also there. Okay. I think that was it. Thanks for joining.